is section A12 on graphing. We're going to be focusing on graphing lines. If you haven't done so yet, just pause the video and print out these pages so that you can follow along with the notes. Now, if we have an equation like x plus y equals 5, that's a relationship between the two variables, x and y. Here's one way to express that relationship with an equation. We can also represent that relationship with a graph. And it's just another way to show this relationship with a picture. Now, graphs can be really powerful tools, so that's why we bother going through these examples. So suppose we have the equation x plus y equals 5. You can create a table first, and then use the table to plot points on the graph. So for example, if you plug in x equals 0 to that equation x plus y equals 5, plugging in 0 plus y equals 5 gives us that y equals 5. So now we have our first entry in the table, 0, 5. If you plug in x equals 1 plus y equals 5, subtract 1 from both sides, you get y equals 4. So we get our second entry in the table. Now there's nothing special about x. You could also plug in numbers for y and then see what x is. So if I wanted to do that, I could plug in 0 for y, so I would take x plus y equals 5, make it x plus 0 equals 5, and then solving for x, I get x equals 5. So that gives me this next entry in my table. When y is 0, x is 5. Now we can plot those 3 points on the xy plane. So first 0, 5. This is my x-axis, and here's my y. So I would go to where the x value is 0 and the y value is 1, 2, 3, 4, 5, and I would plot this point right here. You could also plot the point here. I'll even list it here, 0, 5. We could plot the next point when x is 1, y is 4. So go to the x is 1 on the x-axis, and then up 1, 2, 3, 4. Here's the point 1, 4. And then the point 5, 0. So 1, 2, 3, 4, 5 on the x-axis, and that's where y is 0. Okay, so now if you connect these lines, or these points by a line, what you get is a representation of all possible solutions here. All possible solutions to the equation x plus 5 equals, or x plus y equals 5. So notice that all points on the line are solutions. All points like x, y represent solutions. Here are 3 of those such solutions, but there's infinitely many of those, like -1, 6, this point right here, or 3.5, 1.5, that's like this point right about there. There's infinitely many of them in between and on either side of those of the arrows here, and the graph kind of represents this nicely. All right, so now things that we want to make sure you know about are important key points on the graph. So the y-intercept is the point where the graph crosses the y-axis. Now, the coordinates of every y-intercept are going to have x coordinate 0. The x coordinate is 0 for the y-intercept. So then here is your y-intercept. Usually the y-intercept is this point with an x, y. Sometimes people just shorten it and just say 5 is the y-intercept. But really we know that they mean the point 0, 5 is the y-intercept. Same thing with the x-axis. Wherever the graph crosses the x-axis, that is your x-intercept. And notice that for these points, the y-coordinate is 0. So these are really important points when graphing. Let's indicate those on this graph that we saw here. Right, the first point that we plotted, that has x-intercept 0. This is our y intercept. And here where the y-coordinate is 0 and it crosses the x-axis, this is our x-intercept. So usually when you're graphing, those might be 2 key points that you plot first before drawing the rest of the graph. All right, so now some things about this, about graphing. Sometimes you'll be given an equation in standard form, which is the example that we just worked through. That's where you have ax plus by equals c. So the x and y are on the same side of the equal sign and just a number on the other side. So here are some examples. So think for a minute, well, what are a, b, and c in these 3 examples? So x plus y equals 5, 1x plus 1y. So a is 1, b is 1, c here is 5. For 3x minus 4y is 12, a's got to be 3, b is negative 4, c is 12. And in this last example, a is 3 halves, or 1 half, sorry. A is 1 half, b is negative 6, and c is 37 halves. So this is one way to represent those equations. Now you can manipulate these equations and put them in what's called slope-intercept form, where you can clearly see what the slope is and what the y-intercept is. So the way that we take an equation and put it into slope-intercept form, we do that by just solving for y. So here we can solve for y, and that will put our equation in slope-intercept form. Here, when it's in slope-intercept form, that's the form y equals mx plus b. Whatever the coefficient of x is in this form, this is your slope. And whatever this number is here, the b, this is the y-coordinate of the y-intercept. So you say your intercept is like 0, comma b. Okay, so here's another example. Suppose we take 2x minus 3y equals 12, and we plug in numbers for x and y and plot those points. We can graph it just the way we graphed the last example. Or you could take 2x minus 3y equals 12, and we can solve for y first. So let me subtract 2x from both sides to get y by itself. So you got negative 3y equals, I'll write it negative 2x plus 12. You know, you can't combine those terms because they're not like. And then dividing both sides by negative 3. Let me just continue on down here. So here I got y, because negative 3 divided by negative 3. And now, dividing both of these terms by negative 3, I can split that up as like 2 different fractions. So you got negative 2x over negative 3 plus 12 over negative 3. And now let me simplify that a little bit. This becomes y equals, I like to write this as the fraction in front of the x instead of the x in the numerator there. So negative 2 divided by negative 3, I'll just write that as 2/3 x. And then 12 divided by negative 3 is minus 4. So here I've put the equation into slope-intercept form. So now the slope, m, is 2/3. The y-intercept is 0, comma b. In this case, it's negative 4. And then we can use this data to plot exactly the same line. First, by plotting the point, I'm just going to draw right over the line that's already been drawn. This is the point 0, comma negative 4. And then you'll see in the next section, we can use the slope up 2 over 3. So equals rise 2, run 3. Or I like to say up 2 over 3. To go up 1, 2 units from that point and over 1, 2, 3 units to get the next point on the line. And you can keep going like this, like up 2 over 3 to get this point on the line, and then connecting those points gives you the same graph. All right, so the problem set that goes along with these notes here, that problem set has a handful of questions that are just like these ones, but then there are also some questions that you might think of as review. So make sure to take your time with those, with that problem set, and remember that not everything that's in that problem set has been explained in this video, but that's okay. Try it anyways and ask questions on the discussion board.